Hello everyone, it's Amartya Roy here. Welcome to my channel, and today we will be going to solve the problems in Codeforces Division 3 round 479. So I'll be solving the problems in C++ language, and I'll be using code blocks. So let's get started. So for all the problems I'll be using a standard simple the C++ template. If you face any problem, you can comment on the comment section. I'll be explaining them to you. So let's start with the first problem. The first problem is saying that literature Tana is learning how to decrease the number by 1. She does it wrong with the number considering two or more digits. Tana subtracts 1 from the number by following algorithm. If the last digit of the number is non-zero, she decreases the number by 1. So the problem stating that you are given two integers n and k. You can apply this subtract method k times, and you have to print one integer, the result of the number that will we have after k times of this operation. So what is the operation? The operation is that if the last digit of the number is non-zero, then decrease the number by 1, and if the last digit is 0, then decrease divide number by 10. So this is a pretty much straightforward problem, and here we are taking two variables and we are going to make k operations. Then we have to check the last value, last digit. So last digit if not equals to 0, then I have to decrease the number, otherwise I have to divide by number by 10, and this will give me the answer. So let's check the problem with this test case given. It's 50 and it's right, it's one, it's right. So let's submit it. Submit. So it's showing that the problem is accepted. So we'll be solving the second problem now. Second problem. Second problem is that 2 gram is an ordered pair of capital letters, for example A Z A A Z A. Three distinct 2 grams. You are given a string is consisting of in capital letters. Your task is to find any 2 grams contained in a given string as a substring. Maximum number of times. What is simple string? Okay. So the problem is that you are given a number n, that will be the length of the string, and you have to try every substring of length 2, and you have to print out any 2 grams containing in the substring maximum number of times. So you have to try every substrings like this manner, and then count them and print what is occurring the most number of times. So let's solve the problem. So this is the length, this is the string. I'll be using a data structure named unordered map. First will be string and second will be the count part. So if you are familiar with this unordered map data structure, it will be very much helpful. It can optimize, or you can solve many types of problem but by just using this data structure. So what I will be doing is that I will be going through all of the substrings and store them in the map and increment the count. So the maximum count will be CNT, which will be initially 0, and my answer will be answer which is initially blank. So I'll be having a temporary string here, which will be a substring starting from, okay, so I'll explain it here. Suppose so here I'm starting from 1. Why 1? And it's the n minus 1, because I have to first see these two substring, then I have to see these two substring, then these two. So I'll be starting from here, then from here, then from here. That's why I'm starting from 1. And substring first will be first parameter will be the starting of the string. So for as n is starting from 1, it will be I minus 1 and of length 2. Now my map temp plus plus, if I map temp is to greater than cnt, then answer will be temp and cnt will be my map. And what I have to print, I have to print the output. So cout answer and I request, so this will work. So let's check. It's AB and the answer is AB. It says it. So up till now this is working fine. So let's submit the code. You can see it is running on test number 4, and we'll wait for it to finish, and it's showing it's accepted. So let's go and solve the third problem. Less or equal. Okay, it's a small problem statement. So let's see what it is saying. You are given a sequence of integers of length n and integer number k. You should print any integer number x in the range of 1 to 10 to the power 9 such that exactly k elements of the given sequence are less than or equals to x. Note that a sequence can contain equal elements. If there is no such x, print -1. Okay, so the problem is saying that you are given a number nk. Here n means number of integers that you are given, and k means uh, exactly k elements of the given sequence such that less than or equals to x. Okay, to simply we can say that we have to find a number x in this array such that exactly k elements in this array are less than x. So we can solve this problem. Okay, so first I will make an array. It will store the count of every number. So suppose for this I have one count of 1 is 1. I have then 3, count of 3 is 2. Then I have 1 2 3 4 5. 5 I have count of 1 5 1 3 5 7 10 20. 1 3 5 7 10 20. So count of 1 is 1, count of 3 is 2, count of 5 is 1, count of 7 is 1, count of 10 1, count of 21. Okay, so I'll be sorting the number in the sense of incrementing value. Why incrementing value? Because see, here we have to find a x that will be so such that we have exactly k elements less than equals to x. So if I sort this element in the manner of increasing order, so first I'll be checking for this value. So how many values are there that are less than this value? So for first case there will be 0. So suppose now we are at 3. So how many values are less than this value? 1. Here how many values are less than this value? 1 plus 2, it will be 3. So here we are given exactly 4 elements. So 1, 2, 3, 4. So if I use, see, if I use 5 or 6 for the first case, here n is 7, k is 4, so I need to have 4 elements that are less than x. So this is the first element, this is the second element 3, this is the first element, fourth element 5. So the answer can be 5 or the answer can be 6 also. So see, in the first example 5 is also a valid answer because the element is. So we can start solving the problem. Okay, so first we are taking n and k, then I'll be storing them in a vector. Okay, let's see. First we have to make them in a vector of pairs. So one thing I can do is that I can use the unordered map data structure. So it will be helpful. See, here I'm taking the input, inserting the value in the map, incrementing the count. Now I have all the values and its count in my map. I'll be putting this value in my vector. So for auto ITR equals to my map dot ITR is not equals to my map dot in ITR plus plus. So here I am using auto type iterator. So if you are familiar with this, it can reduce a good amount of writing. And vector dot pushback, I'll be inserting a pair, so that's why I'm using is second brackets, and it will be the value of ITR first one and ITR second one. So let's just check if everything is all right. Okay, here stem, and now here I should be okay. Okay, up to this point I'm good. Now I have to sort this vector. Here I'm using a third parameter for the sort function because this vector is in pair function. So just see this. If you're familiar with this thing, it can be really helpful in competitive coding. So I'll be sorting them in incrementing manner. So first increment less than and b first. So just to see whether everything is working fine or not, I'll be simply printing the values of the vec first. So let's try to run this code. If everything's alright, it will run correctly and see whether it's okay. See, one is you can match it with this. Okay, it's not good actually, but at least you can understand. Here 1 is 1 times, 3 is 2 times, 5 is 1 times, 7 is 1 time, 7 is 1 time, 10 is 1 time, 20 is 1 time. So up to now my code is working fine. So let's move forward. So what I have to do now, I have to start making the count. Okay, so what are the cases if there is no answer? It can happen that when we are traversing the array from left to right, we either don't see k for the summation of these values. See, here it's wanting exactly k elements of the sequence to be equals to or less than x. So if I just count equals to 0, so for x is 0, plus plus, if anytime k cnt equals to greater than k, then there is not any answer for guaranteed. So I'll be using a flag variable greater than k, then flag will be 1 and break. Otherwise I'll be adding the values from second. Okay, so here what I'm doing is that I'm going through the whole vector. If anyhow any point uh, uh, as count is greater than k, then I'll be setting a flag and I'll be getting out this loop, or otherwise I'll be doing this. So if flag equals to 1, there is no answer, I'll be printing -1. And if else otherwise what I have to print, I have to print the value of x. So less than and okay, I'll actually have to put one more condition here. If cnt equals to k, then for sure this is the answer. So I can answer equals to the value of the first element. So I'll be printing the answer. So let's check whether it is working. And it's not. So let's see, where is the problem? The problem may be vector to size I is 0, cnt equals less than greater than k, break. Okay, actually I have to use a break statement here. I forgot to add this, otherwise it will be adding values. No, still it's a no answer. So let's see the array 1 2 3 4. So this is for 1, it's 1, it's plus 2 equals to 3, it's 1, it's cnt is 4, k equals to, so k equals to cnt equals to k, answer equals to 5. It should be 5, I guess. when it's coming here, let's just print the value. It's coming here at 3, means 0 1 2 3. Why 3? There's some mistake I have done for sure. Let's see. Okay, I have committed a mistake here. Actually what I'm doing is that I should first add the first variable. So suppose the answer itself k equals to 1. So when I'm at the first variable, I'm first adding the value to 1. If it is greater than, then error. It's equals to, then correct. So now it's showing the correct answer. For this there isn't any answer and everything's okay. So let's just final round. But I was thinking that if k equals to 0, means if k equals to 0, then I'll be starting from the first element. So what will be the answer if k is 0? Think for once. It's given that I have to find a number in the range of 1 to 10 to the power 9. 1 to 10 to the power 9. And anyway the values are in the range of 10 to the power 9. So if the value of k is 0, then I have to see the first element. Okay, so see here I have one extra condition, like if k equals to 0, then if the first element is greater than or equals to 1, if the first element is greater than equals to 2, then 1 can be answered because the values should be in the range of 1 to 10 to the 9. So and greater is the first element value is greater than equals to 2, then the answer exists. And what will be the answer? And what will be the answer? The answer will be vector 0 dot first minus 1. Otherwise the answer will not exist. If k not equals to 0, otherwise. Okay, so I'll be changing here a bit. If this, so let's try this with one example. Like suppose I have 4 variables 1 2 3 4. I want 4 variables k equals to 0 1 2 3 4. Answer will be 1. 4 variables k equals to 2 3 4 5. Answer equals to 1. And let's try with this again. It's correct. 5. It's correct. So let's just try whether it's getting accepted or not. As you can see, it's running and boom, it's accepted. So let's solve this next one. Divide by 3, multiple by 2. Let's remove the board part. So what's the problem saying? Polygraph likes to play with numbers. Okay, just wait, I will be making a new one. Okay. The polygraph likes to play with numbers. He takes some integer x, write it down on the board, and then he performs n minus 1 operations of two kinds. Divide the number by 3, it must be divisible by 3. Multiply the number by 2. So after each operation, polygraph write down the result on the board and replace x by the result. So there are n numbers on the board after all. We are given a sequence n numbers in the polygraph write down. The sequence will be arbitrary order in order to do the sequence mismatch. The board order, the problem is to rearrange the element polygraph. It is guaranteed that the answer always exists. Okay, so what the problem is that you are given a number n, then polygraph performs two type of operation. If the number is divisible by 3, then he divides by 3, or he multiplies the number by 2. So let's see one example: 486312 So this is the sequence they are saying is the answer, like 9, then they divide by 3, 3 then divide by 6. Okay, so it's not compulsory to divide a number by 3 whenever it is divisible by 3. Here you can say 3 is divisible by 3, but they are multiplying it by 2, so I have to rearrange it and come with the sequence, and it is guaranteed the sequence always exists. Okay, so these type of problems, they can be solved by graph, but I'm not interested in solving the problems in graph. So I'll be trying to catch some properties of the solver. So let's try to catch some properties, like here it is 4, 8, 6, 3, 12 and 9. So from 4, if we multiply by 2, it is 8. If we divide by 3, we can't have 3. 8 multiply by 2, 16. Divide by 3, we can't. 6 multiply by 2 equals to 12. If we divide by 3, it's 2. 3 multiply by 2, it's 6. Divide by 3, it's 1. 12 divided multiplied by 2 equals to 24. Divided by 3, 4. 9 divided by multiplied by 22 equals to 18, divided by 3. Okay, so let's see. So all the numbers, there will be a starting number and there will be ending number, and as the number is a multiplication of x, either divisible by 3 or it's multiplied by 2. So you guarantee that there isn't any number that will be repeated from these three numbers? I guess we can guarantee that. Let's suppose x can be any variable. So if it is divisible by 3, then we divide it by 3. Can we get back x again from that number? If we get back x again from this number, then there should exist a duplicate variable of x. So either x can be a odd number or even number, and it can be divisible by 3. So if we suppose x is a even number, so we can represent this 2x. So after this operation, only operation we can do is that either divide it more by 3 or multiply it by 2. If I multiply it by 2, it will be 4x by 3, or divide, it will be 2x by 9. So you can say that anyway there is only multiplication by 2 or division by 3. So you can't have uh, this number back from this type of operation. You can say this is not a reversible type of process. So we can safely say that all the numbers is in this equation will be unique, at least I guess so. If I'm wrong, you can find any counter example, you can write on the comment box. So let's see if I able to find any property. 4 8 is here, 16 is not here. Okay, 16 is not here. 6 12 2 12 is here. 3 6 1 6 is here. 12 24 4 and 9 18 is not here. 3 is here. Okay, so let's try to think. 9 is the last operation. 9 8 8 16. Okay, so one thing we can do, wait, let me check once. 16 12 12. Yes, I think that the last number that we have in our original sequence, like here it is 8, as the all of the numbers are unique, we will not be having any uh, divisible of the last number. Like if it is, if if we consider the last number to be x, then we are sure that if x is divisible by 3, there will not be any number x by 3 in this whole array, and we will be sure that there will not be any number 2x in the array, because it's the last number, and as I have proved that there cannot be any duplicate numbers. So we can just try out every number and see, like see here 8, we don't have 16 in this whole array, and we 8 is not divisible by 3, and for any other number, like say 4, we have 8 in this array. For 6 we have 12, for 3 we have 6, for 12 we have 4, for 9 we have 3. Only for 8 we don't have both of the numbers. So we can just run through the array and check what is the first number that isn't have any value multiplied by 2 or divisible by 3 in the array, and after finding this array we can backtrack and get the answer. So let's start solving the problem. Okay, so what it is, it's n, the length of the array, vector big of size n, vector of size n, then for okay, so what I have said here that I'll be checking every value and try to find the last element. Then last for int I0 I should and for checking every value I can use again unordered map. Actually I don't need map. I can use unordered set my set last value my set. So my set dot insert AI. So every value will be inserted in my set, and then for every value I have to check whether I have a first I will check whether for x I have 2x in the set or not. So for I'll if it exists then it's not the answer. If it doesn't I have to check whether I have it is divisible by x by 3 or not. If not then it's the answer, and if it is divisible by 3 but the array doesn't exist x by 3 then it's the answer. So I have to check like see if vector I multiplied by 2, I have to check whether this exists or not. Then my set dot find I have to see if it exists is not equals to my my set dot end. Here I'm checking if it exists then continue, it can't be the answer. If and if it doesn't exist it will come here if vector I divisible by 3 equals to 0. If it is divisible, if it is not divisible then it's guaranteed the answer, it's I0. I'll make a break here. If it is divisible by 0 then there shouldn't exist, there it shouldn't exist. So let's see if it is divisible by 3, if it is not divisible by 3 then it's the answer. If it is divisible by 3 and if the answer exists in the array then same I'll have continue. So let's see if it is giving me the correct result or not. Let's see. So answer will be 8. It's taking time. It's 8. Okay. It's 28. It's 28 and it's 1 whatever it is. Okay. For now it is working perfectly fine. So for every element I have the last element, and as I have told you that all the elements are unique. So now I'll be starting from back. So I have to make an array of answer vector vec answer. So where until the answer length is n. So while vec answer dot size is not equals to n, right? The first element will be vec equals to last element, it will be last element. Then I'll be okay. I have to backtrack means 8. I have to check whether I have, see here I'll be backtracking. So I have the last element, I have to find the previous element. So what the previous element can be, the previous element can be 3x or it can be x by 2. Okay, so I have to see if actually what I can use stack, it will be useful. Okay, so here I'll be using stack stack data structure my st dot push will be last element, while my st dot size is not equals to n. Okay, so now this will be good. When my st, okay, let's take the first element. Then my st dot top element, I have to first see this 3x whether it is in the array or not. So if my set dot find var into 3 is not equals to my set end, means if it is in the array, then I have to simply push this val into 3 in my set, and see if it doesn't have 3x in the array, then it should have x by 2. So I can safely, without checking any condition, can write x by 2, and then while my set dot empty, while my set isn't empty, I'll be printing out the values top st dot form. So let's see whether it is working or not. It's slow, you know. I don't know, maybe for the video recording part it's acting slow. So looks like 9361248, it's good. 126 42 84 28, and I think it will work. So let's, okay, internet connection is gone, so just wait for a minute and it's here. So let's submit it. I'll change something to show it. It's good. So let's see, it's running on the test cases. So if it get accepted, we will be having two more problems, cyclic components. Okay, so it's accepted. So let's start the next problem, cyclic component. Okay, so it will be a graph problem, so it will be a good problem. So let's start solving this problem, and the time limit is 2 seconds. You are given an undirected graph consisting of n vertices, m edges. Your task is to find the number of connected components which are cycle. Your task is to find the number of connected components which are cycle. Here are some definition of graph theory. An undirected graph. Okay, so an undirected graph consists of two sets of nodes and sets of edge, and edge connects to a pair of vertices. All the edges are bidirectional. You can't have a vertex to itself. Two vertices U of V are connected components if and only if there is at least one path along edge connecting U and V. A connected component is a cycle if and only if its vertices are reordered, can be reordered. This is the main point. In such a way that first vertex is connected to the second vertex by an edge, the second vertex is connected to the third vertex by an edge, last vertex connected to the first vertex by an edge. All of the described edges are cycles are distinct. All the described edge of a cycles are distinct. A cycle can't contain any other edge except the described. By definition, a cycle containing 3 or more vertices. Oh, so 2 will not work. By definition, a cycle contains 3 or more vertices. So there are 6 connected components. 1, 2, 3, 4, 5, 6. 2 of them are cycle. 7, 10, 16, 7, 10, 7, 10, 16, and 5, 11, 9, 7. 5, 11, okay, 5, 11, 9, 15. But this is not. Why this is not? because we can't order the vertices. See, if I start from here, then here, then here, then where should I go? 4 or 10. So okay, so what I have to do, so I have to first find the number of connected components and then store them, and after storing them I have to see how many in how many connected components I have connected components with minimum of 3 nodes, and from them I have to see whether the connected component make a cycle or not. So let's draw some pictures. Here, suppose these are the part. This is making a connecting component, that much I hope you can understand. If you don't know the algorithm how to find the connected components, you can drop a comment. I'll separately making a video on this for helping you. So this is a connected component and this is forming a cycle, or this can be also an example, but this can't be. So why this is not a solution? Because there is an extra edge. So every cycle should at least have this form. Means you can just check whether in the connected component every node has a degree of 2. Degree you can understand in degree, out degree, as this is a unordered map. So degree is a simple term. So if I just check whether the degree is 2 or not, it will work. So let's start solving the problem. In M, in M, in M. What is M? What is M? N is number of vertices and edge, M is edges. So I'll be making the graph using vector. So vector graph G of in edges, in vertices. Okay, in vertices. Here see, this is a wonderful structure. Actually, this is a array of vector. This is the array representation and this is a vector. It can means I'll be using adjacency list representation. So let's start it. Okay, sorry. I'll be having m edges. I will show I will show this in I plus. I'll be taking two variables a, b, a, b. See, here I have decremented value by 1 because here the edges are from 1 to the edges value starting from 1, but array start from 0, I'll be using indices from 0 to whatever in -1. So I will have vector a dot push back b. What I have done, it will be b a. It's represented I have a edge from a to b, I have a edge from b to a, as this is a unidirectional graph, so I'll be using this. Now sorry, now I have to find the number of connected components, so I'll have to run a DFS. So first try to find the number of connected components. So I have to use a visit vector visited of size n, and let's in I equals to 0, I equals to 0, I plus plus. If I is not visited, if I is not visited, you may be knowing that by default the value of vector is 0, but I am specifically focusing here. So I'll be running DFS here, DFS. So DFS will be, I will having the graph, the starting, the visited, let's see what more is we needed. Write DFS the vector graph, then the starting node, then vector visited. But here I'll be using the reference because I have to keep update my visited vector. So for the loop start is visit, aha, for loop start is visited, so it is 1. Then I have to visit the other, oh sorry, I forgot to point out the connected components. Then cc equals to 0, cc plus plus. So for int I belongs to g start. Actually this is a very beautiful presentation of for loop in other way from a vector. If you don't know this one, you can ask me in the comment section. I will explain in next video, but you can search on Google, and this is a handy one. So dfs g, then starting will be from I, then I'll be using visited, and that's all I guess. So let's see whether it is correct, working correctly or not. I guess this is the example of this one. So I'll be having 6 connected components, and hooray, it's not working. So let's see where I have committed a mistake. Okay, let's see. N is the number of edges, the number of vertices, edges, number of A B go B, N visited. If visited I equals to 0, here it is not equals to 0. Okay, not visited, sorry. If visited equals to 0, here again, if visited I equals to 0, not visited. Now let's see. Boom. Boom. It's 6. It's working. So next. But I have the connected components, but I have to store the connected components separately. So let's make a same thing again. Let's make a array of vector. It will be connected components. Let give it a name of cc capital. How many connected components I can have? If all the edges are disconnected, I can have maximum of n connected components. So I'll be adding this cc. Let's add this here, capital cc vector ll cc. This is a part of a connected component. So connected component, this will be added. Okay, okay, I have to cc this counter. This cc will act as what is the number of connected components, so I can use it as an index. See, it's a good one. I'll be using the reference because the value will be changing here and it will affect it here. So cc dot push back will be start, and that's all I guess. Let's just check once. So I'll be having that many connected components, and for all the connected components I'll be printing out them. cc j belongs to cc, it's from I. So let's see, j. there is an error. Okay, sorry, I forgot to add the part CC and then CC. Let's see. Okay, it's showing something. I don't know whether it is correct or not. 0711. Okay, 0. As you remember, I have changed in my code AB to -1, so it will, I have to match it 0711, so it will be 1811, 1812, 1 it is 2, 212, 3 4 313, so 313, where 313, 414, 5, it's 16, 17, 1 2 3 4 5 6. Where is this one? Oh, this one, 4 10 8 19 5 15 19. Okay, so my code is working correctly. Good. So now I have all the connected components, and what are the nodes in the connected components. Now I have to see the connected components which have elements more than 3, because it is showing that by differential cycle, and for each components I have to see whether the degree of the components 2 or not. So let's start making the answer equals to 0. So for all the connected components, if cc I dot size is to greater than equals to 3, only the answer can then exist. And then for int j belongs to all the components of the cci, I have to check if graph j dot size equals to 2. Otherwise, if not equals to 2, then the answer don't exist. So I'll be using a flag variable 0. If flag equals to 1, and it will be as a break, so it will break from here, it will break. Otherwise, how can I increment my answer? If it is greater than c, if c was fine, let's see. So for I equals to all the values, for all the connected components, the size of the connected components greater than 3, and if the if all the elements of the connected components have in degree equals to 2. If it's not 2, it's out from here, if here. So if flag equals to 1, the answer don't exist. Otherwise, flag equals to 0, I have an answer, and for every answer I have to make the flag equals to 0. So I have to just print out answer. What? It's 2. It's 2. And for 1 it's on. Boom. Yes. So let's guess. My code is working good. So submit it, and hope it will pass. Okay, so it's accepted. Good. So for now I'll be solving the last problem. last one. See, consecutive subsequence. How many lines this code was? It's almost for 15. Okay. So let's start solving the last problem. Consecutive subsequence time limit is 2. You're given an integer array of length n. You have to choose some subsequence of this array of maximum length such that this subsequence form an increasing sequence of consecutive integers. Consecutive integers. In other words, the required sequence should be equals to this one, okay, of length k. So what I'm given an integer n. I have to print any maximum length subsequence for a given array from the increasing subsequence. So this is a famous problem, means it's actually a customized version of this famous DP array longest increasing subsequence, but I have to print the sequence here too. So what can I do? If you are familiar with the longest arithmetic subsequence, LAS, you can solve the problem. In GFG they have the solution of this problem, but as I have to print this one, so the solution that I have there, it's in square and it's 10 to the 5, so 10 to the 10, and it's can't be solved. So I have to think it's other way. I can, means the logic is pretty much simple. See, I'll write it here. You have to make a DP. First I will tell you what's the solution in GFG. If you want to explain me better in if you want me to explain this problem in a better manner, you can submit your query in the comment section, and I'll be explaining this DP problem, a longest increasing subsequence. Increasing, I wrote it's actually LIS. LA is longest arithmetic subsequence, and here we are talking about LIS. Sorry for me, it's the LIS solution. So LIS solution, the DP, this will be the DP part for everyone. The DP will be storing the maximum value, the maximum length of longest longest increasing subsequence up to index I. So what I will be doing, for this index I'll be trying this value, for this index I'll be trying this value, for this index I'll be trying this and this. So you can say see that the complexity will be in square. Another way I can solve the problem is I can use a map data structure, map DP. So for every DP I, the solution will be maximum of, either I take the last value or the current value, I guess so. Let me think whether it is correct or not. So here I representing the sequence that will be ending with a variable I. So whatever the sequence is A, B, C dot 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 C, the last value will be I. This manner I will be storing this. Means see, the DPI will be maximum of DPI minus 1, means as the question is asking for a longest consecutive, so I minus 1, and if it is maximum then it will be plus 1, otherwise it will be simply dpi. So let's try to implement this. I have given n. See, n is the length of the vector. In for n I which is 0 equals to less than then I'll be using a map dp. Then for okay, so I'll be starting from left to right for all the variables in the array. Dp I will be maximum of dp I minus 1 plus 1 or dp I itself. Then I have to find the maximum value, so I have to find the maximum. So ll max length equals to initially 0, and this will give me the last variable, last. So if max length, sorry, if dp I, it is giving me the longest length, it is greater than max length, then the last variable will be I, sorry, oh sorry, it will be vector I, vector I dp vector I. If dp vector I, okay, means we are traversing through the variables now. Here one I is the last element of the longest increasing consecutive sequence. So here the first variable minus 1 and plus 1 if it is greater than, or the variable itself dp max length, so last value will be vector I, and max length will be this one. So now I'll be having the, so let's just see whether it's getting me the correct answer or not. Max length, hope it will be working fine. It's 4 and it's 4, it's 2 and it's 2, it will be 6 and it's a 6er. So now I have the length and the last variable, so I can simply go through the vector from right to left, and I have defined anywhere, no, right to left, and I can have the answer. See here, I equals to n minus 1, I equals to greater than equals to 0, I plus plus. So if vector I equals to what I have to store, actually I have to store 2 3 5 6. What is this? I have to print the indices, I guess. Subsequent increasing consecutive one to longest subsequent increase on the on the single line print the indices. I have to print the indices, not the value, obviously not the value. So if vec I equals to my last variable, so I have to push ends dot push back I, and then last value will be minus minus. So now reverse ends dot begin ends dot end, So now I have to print the size too. So cout and dot size. Now int I belongs to ends. I'll be printing I. Let's hope it will be working good. 1 2 4 5. Okay, I know what's wrong. Here 1 is from 0, you know, because for vector is starting in this is 0, but they are considering from 1, so this time it will be matching. 2 3 5 6, good. 1 4 1 4, it's good. And let's check the last one. 1 2 3 7 8 9, 1 2 3 7 8 9, and boom, submit. And hope it will be submitted. It's taking time. Don't know why. So many test cases and it's taking so time. I'm getting bored. And it's accepted, so all the problems are solved. So thank you for watching. If you have any queries or anything that you want to be explained more clearly, you can write on the comment section. And please do subscribe. I'll be uploading more videos like this. If you want to focus on placement or competitive coding, you can tell me in the comment section. I'll be posting videos based on them specifically. And if you think that it's a good content and it will be helpful for your friend, so don't forget to share, like and subscribe. It's Amartya, and goodbye.